of all, we're gonna open your eyes so you can see who you're gonna call if you wanna be free. GLOBEBUSTERS! 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 Who you gonna call? Who you gonna call? Who you gonna call? Yeah! GLOBEBUSTERs! GLOBEBUSTERs!
Oh, that was unexpected ending, but welcome to GLOBEBUSTERS. We are live on Rockfin. I had it set up on the wrong one, but we got it fixed. So welcome to episode 10, or season 10, episode 3. Yeah, we called it Heliocentrism, Shrouded in Darkness. This will be a good show. My boy Zack is here with me. How's it going, brother?
Hey, Austin. Not too bad, man. Not too bad. The weather is finally starting to break around here. Feel sorry for all of you up north where it's just miserably cold. I hope you're doing all right. I've been saying, I try not to pray too much. I don't want to bother the creator, I mean, I speak to the creator all the time, but I usually try not to ask for things. But when it's times like these, I always do. I just ask, can you please, let people's, water lines not freeze, let people's, because that stuff sucks. It does. And right now the prices on everything are so high that home improvements are not, that you can avoid, or not things you really want to. That neighbor lady is spending 16 grand to get a new furnace put in here. Yeah, hers just went out. And yeah, it's hard times. So I have been saying prayers for people. And I think, that's the kind of stuff that he wants to hear. Not praying for money or praying for fame or, just paying for peace of mind for others. So that's what, yeah. Yeah, I worry about my family up north. They're up there right at northern Indiana. It gets real cold by Lake Michigan this time of year. So yeah, if you got any of those extra prayers in you, just, throw some of those out there. The kind that are just, for everyone. Feels good.
Nice,
How you
bro.
been, man? How you been?
I've been good, man. A lot going on. Trying to keep up with everything, brother. So yeah, we launched Life Reset. We're getting that set up, and I'm just trying to figure out what to do with the channel, what I need to take off of it for pilling and getting it started back up, blah blah blah. And I have a debate tonight. So the show may end a little early, so everyone knows, just because I have a debate tonight. And I was fasting up till today. I fasted for 84 hours. And,
Wow, how did that go, man? How are you feeling?
it's actually pretty awesome, bro. So like the first little bit can be tricky. Like I eat 1 meal a day, so for me it's about 7, 8. I get hungry. But then I just drink the electrolyte blends and my hunger went away. It's really a trip. So it wasn't really that big of a deal. After like 48 hours, maybe, I started like having lots of energy and feeling like euphoric in a way. So it's
That's
actually very
awesome.
cool. Yeah, it's very cool. If you can get past the first couple of days, depending on maybe how big you are, how often you eat, it may take you till day 4 to really get there,
Mhm.
Yeah, dude, it was really cool, man. So
That makes you just in awe even more of, what some people have done. 40 days of fasting.
yeah, it's crazy. I will say this. I felt like I could have easily kept going. All I have eaten is like this little bit of brisket, like just a little small amount. I wasn't even really hungry. I only ate because I wanted to work out kind of hard and I wanted to end up gaining some weight and blah blah blah. But I don't know. It's pretty crazy. I can actually see how people can do really long times because when you get to that point, it's just like gets easier. Even though it's kind of counterintuitive, you would think it keeps getting harder. Not at all, bro. Like it's really wild. I don't know about 40 days sounds insane. We have people in our group doing a couple weeks. I think I could have probably done a couple weeks, honestly. Um, so yeah, anyone that's never tried it, they should try it for sure.
Yeah, I'm
Where's
sure
the
once your
debate?
body gets used to that, and as long as you keep giving it those electrolytes and the liquid you need, you probably feel kind of great because your body's not putting all that energy and effort into digesting all this food all the time.
Oh yeah, the science behind what happens to your body is insane. You go into what's called autophagy, and autophagy is your body just starts repairing all of its cells. It's crazy. Jeran did the fast as well. Said he was feeling really good. I messaged him like, bro, I feel like I'm tripping. I feel amazing right now. And he was like, me too. Your body goes into autophagy, ketosis. You begin to get your body creates HGH. Men begin to produce tons of testosterone. Your body becomes like superhuman, bro. It's very crazy. We got people 20 years of arthritis gone, type 2 diabetes gone in a matter of days, like crazy things. Not medical advice, but psoriasis. Oh, it's there forever. Wrong. Fasting made it go away. Restless leg syndrome, high blood pressure, crazy, crazy list of things. So, yeah,
Yeah,
I
I
encourage
fast
anyone to try it.
regularly. I don't do it for very long, usually 24 to 36 hours, but I'll do it about once a month. I think today is my day. I don't really plan it out either. It just kind of happens. Like I haven't eaten anything today. I've had a couple glasses of juice and a couple coffees just, in the early light. But yeah, I'm not even hungry right now. I know it's only 3 in the afternoon here, but yeah, I probably won't eat tonight. I just don't feel like it. Cami was asking me, "Want me to make you something to eat? Are you hungry?" No, I'm just not hungry.
Yeah, dude, the real glitch, man, is drinking electrolytes. Like when when you feel hungry, your body needs electrolytes. It's really wild, but yeah. Someone asked, "Where's the debate?" It's on modern day debates. It's 2v2 with Mercedes. Do you know who that is?
No, I don't think I've seen her yet.
Yeah, I think she just started, and I don't know. He just asked me to do it. I said, "Sure." I don't like 2v2s, but whatever. Cool. All right.
Who is
Well,
it up against? Anybody
I don't know. Some dude I
worth
debated back in
mentioning?
the no.
Oh, okay. Well, yeah, just do your thing. You know
Yeah.
you got this. It's not so much for flat earthers, it's for all the people that are out there just seeing these things for the first time and watching you make fools of these people.
Yeah, for sure. I should 2v2s get chaotic. Points never get drawn out and whatever.
Yeah.
All right, cool. So I think Zach has a few things he wants to talk about before we get into anything else. That's correct? Yeah.
Yeah, yeah. The I just want to talk about electricity a little bit before we get into the heliocentrism, shrouded in darkness. And I'm gonna start off at the very beginning with electrostatics. And we're just like maybe every couple weeks, once a month, I'll be doing a live demonstration and people can ask questions and we'll go from there. But I'm going to start off how I did when I first got my Van de Graaff generator and started playing with it and just learning about how electrostatics works. And most people think electricity, you're thinking fast, real fast moving things. The electricity through the wires, it moves so fast, it's almost the speed of light. But when you get to electrostatics, I mean, I know lightning is fast, which is electrostatic. That's the breakdown of it. But when it's stable, it's not moving all that fast. Um, even I'll show you here. Let me see if I can hook my phone up to this.
And
I
let me
should
quickly
be.
say one of the alleged rebuttals from even like FED and stuff like that is static means not moving. Ha ha ha. Dude, first of all, everything is intrinsically vibrating and slightly moving. And if I go and touch a doorknob, right, when I have like electrostatic charge, it moves to the doorknob. There's a transference. So it's the study of stationary charges or barely moving charges, like in very simple terms. So it's not that it's literally and entirely void of any movement whatsoever. Yeah, just because it's called static doesn't mean that. Okay. Anyway, continue.
Yeah, no, you're right. It's very slow. Like that little discharge that you had there, that was it breaking down and moving very fast. But even when you go to reach for a doorknob and there is no discharge, there is still electricity flowing from your hand to that doorknob, from your hand to everything around you. Everything is electrostatically charged, and it's at different amounts, which is the really neat part about it. It all goes in with density, you know? So you have two objects in the same area. The denser one is still going to be holding more electrostatic potential and feeding off onto that lower one, trying to make them equal, even though it never will. It's kind of like air pressure. It's never ever going to be the same everywhere down here. We have too many things changing it. The sun and the moon, the downward vector, all these different things are affecting the gas pressure in this place to where it can't equalize. It never will, unless all those things stop. So it's a very slow, and it can be fast. There's tornadoes and things like that. That's when you have very great potentials. It's when you get these really slow, potentials that drain off.
Yeah,
Think of it as current.
You have like electrostatic induction, right? So it causes a redistribution of the charges, and that does require some movement.
Yeah.
Yeah.
And it's very small. It's very weak. Let me turn around this camera here. Okay, they got the mic muted. Okay. Okay. Give me 1 second.
Yeah, no worries. I'm just addressing that thing in the meantime. Like people, of course, static does mean not moving, but in reality, that is not necessarily the case. All right, I'm gonna add to the stream.
Yeah.
Then I'm gonna make it big here. There we go.
Back it up a little bit. We'll point that a little more down. It's not letting me get all of it in. But there, okay, you see the bottom there? To the left, we have just a incense. We're going to use that a little bit later. So we have the Van de Graaff generator, the discharge wand, and then we're going to come up here to the Van de Graaff generator. Now, all I have on here are a bunch of little pieces of tissue paper. Now, this is considered conduction. And because it's a sphere shape, and we'll get to other shapes, at maybe the next demonstration, but the sphere is going to discharge all this electricity radially equally, like a 1/r squared, like it's a point source. So you're going to see all these things sticking straight out when I give it a crank. And the neat part is with electrostatics, you'll see I don't have to keep turning it. It takes a long time for this stuff to drain off, even just this little stuff like this. It might take a second to get it up there and get them all standing out. This one on top is being not cooperating, and the one up front here by you, yeah, it's weird. Let me we'll touch these a little bit, get it over there. Okay, now I'll stop. And it doesn't just go away. That static charge is still there. And now it's dissipating, but there's no current behind the electricity. So it isn't flowing real fast. It's like a river, a current in a river. The faster the current, the faster the water's moving. Well, same with electricity. There is no current. It's static. It's standing still like a pond. There is no current flowing through it. Now, the neat part is you can actually bend the electric field lines. You'll see when you bring something that has a higher or lower charge to it, these things are going to attract to it. They're going to want to try to reach out and grab it, and that's the electric field lines actually bending. Now, you'll see they always still want to come out of it at straight angles from the sphere. They always still, when they touch the sphere, they want to be perpendicular to the surface. And it's still just from those cranks at the beginning. See how long it's taken for this stuff? I can even touch them, and it doesn't, because paper isn't that great of a conductor. So it's flowing through the paper. It's just doing it very slowly. So it's an insulator. It doesn't mean it doesn't ever release the charge. It means it really just slows the charge down. It takes a lot longer for that charge to release from that. Whereas a conductor, it'll just run right through it or right around it across the surface. I've actually had balloons stay charged up for over a week. A rubber balloon, because it's such a good insulator. I polarized a balloon, and I had it hanging in my room, and I can go up there with the little glass rod, and I could actually turn the balloon around for over a week because it was still holding on to that just an electrostatic charge. Stayed on a balloon for over a week. So these things, the charges are everywhere around us. Everywhere. I like to think of it, if I could see the electric field, I think it would look kind of like the Matrix, not with the numbers and all that crazy stuff that Neo sees in it, but the edges would have sharp lines, flat surfaces would be more, kind of, you'd probably still put off a little color, and then the hollow things would really be black and dark. And I'm going to show you why that is right now. Is there anybody with any questions in the chat there, Austin?
Yeah, if anyone's got any questions at GLOBEBUSTERS or me or Zack, and then I will check them. And also, of course, if anyone super chats a question, we will check it. So I'll go ahead and say shout out to Elliot Brand. Don't know what that means, but thank you for the 331 super sticker. And let's see. Yeah, just a reminder, at GLOBEBUSTERS or at witsitgetsit. Matthew De Gregorio. I always say it wrong, but thank you for gifting the one GLOBEBUSTERS membership. Shout out to Flat Out Fudge for getting it. Let's see. Okay, very. Someone said, "How does the generator work?"
Oh, it's just a hand crank generator. It's creating friction. There is little plates. There's one at the top here and one down here. And it's creating a friction through induction with this is rubber right here, and these are aluminum. So when you rub them together or even rub them just real close, it'll create a static charge. The positive gets gathered up here, or the higher potential gets gathered up here, and the lower potential gets gathered and discharged out through this wand right here. It runs through that wire, and all it's doing is separating a charge. That's all it's doing at high potentials, but there's no current behind it. So that's why I got the hand crank one. The ones you can plug into the wall, they can zap you pretty good to where, I don't know, it'd probably hurt. And this one, I mean, I've been shocked with 250,000 volts. Now that's just static. And it wasn't fun, but it didn't, it didn't hurt me. So that's why I stick with this kind of stuff, to where I don't want too much charge. So, okay, now we've placed a nail on here, all right? And as you can see, now we broke the symmetry of the sphere. It's no longer a sphere. There's a big point coming off the end here. And what you're going to see now is these are going to have a lot more trouble standing up. It's not going to be equal anymore, the amount that's being distributed, because most of it is going to want to come down here to this sharp point. That's why I always say the edges of things are going to be sharper. You're always going to see it sharper when you're at an edge of a surface. So we'll start cranking it, and I will continue cranking it. As you can see, they don't really want to stand straight up. Now, even though it's coming off a lot more on that, it's still holding a little bit of a charge right now. I can touch it and it all falls. Crank it up, but it doesn't want to stand straight up. It can't anymore. There's not as much charge. And as you, like over here, it doesn't want to stand up at all. I don't know. Some of these will get, it's amazing. This will get polarized. And this will stick down to the surface right here. It's really neat. It reminded me of a solar flare when I was playing earlier. But yeah, it almost seems the one that are closer. Oh no, these are sticking out okay back here a little bit more. But this one, yeah. And then I'll take this off real quick. Put that back down here. And you'll see they all want to stand straight up again. So having it not a nice equipotential sphere, ooh, that one got me. But adding a nice sharp point to it somewhere is going to change the electric field. All of that electrostatic potential is now trying to rush off of this point and equalize out with the air around it. Now this is ionic wind. And we'll end it on here. I don't want to make them too, let me go grab a lighter. I don't want to cover too much stuff all at once. I notice when I do that, people tend not to get it as much. So we're gonna have quite a few of these, but it's just electrostatics, the basics to how all this stuff works. I mean, even you right now now you're touching the ground, most likely, right? You know, even if there's an insulator, we know that electricity still travels through insulators, right? Not fast, depends on what kind of insulator it is, but electricity will still travel around the edges of an insulator and keep dissipating. So you're touching the ground, you're the same charge as the ground. Now you may be insulated on shoes and things like that, so your charge may be a little bit higher than the ground, just a little, because you're gathering a little charge and it's taking some time for that charge to dissipate through the soles of your feet. But nonetheless, that electricity is always flowing and it's coming from above, right? I don't know where it's coming from. We'll get into how the field is created in a little bit later. I know Austin loves that subject, but this is just how the electrostatic energy is reacting, depending on what shape the item is that it's coming off of, and what the electrostatic charge around it also is, and what it does to the environment around it. So we're going to light this up. Oh, come on. Let it burn a little bit longer. It's been a while since I've burned incense. Come on. There we go. We're going to let that settle and just kind of start. Can you even see that smoke?
Not really.
Here, I'll move it closer to it. Oh, I need a better background here. That's what it is. Okay, give me 1 second.
Your black shirt may help a little bit though. There you go.
Okay, I gotta watch my breathing now. I want it to come straight up. Well, you'll see. You can see it now. As soon as I crank this thing, you'll see it start blowing the other way once it gets up to the needle.
Wow. Yeah.
That's just that's not any current involved, you know, but that's ionic wind. I can actually feel it on my hand when I do this. When you get kind of close right there, it feels like somebody is blowing on my hand right there. But you can see the smoke just being pushed away. Now, some people say, oh, well, it's the particles that are being charged, not the actual air.
Yeah, they'll say that it has water vapor and
Yeah,
small
well,
particles in it.
yeah, well, show me a place on Earth, that doesn't have some kind of particulates in it. But yeah, that's ionic wind. So
There are actual generators that run off of that.
Oh yeah. I think this is the only way to really know how much power is actually up there. I don't think we've measured it perfectly. When we get to high altitudes, the way they do it just isn't. It's a lot of presuppositions, I'll say. And I'm not big on those. Yeah, ionic wind. And as you'll see, it's going towards the low potential right here. Like, I'll even move this out of the way so it's not that. Even without that, it still blows it over there. Yeah, electrostatics, folks. A lot of it has to do with the shape of things. Like I said, think of the way Neo would see the Matrix when he's in his Neo mode or whatever. Flat surfaces would be, light green. The tips of things would be real bright green. And then anything concave, like a bowl, on the inside of that would be dark. The electric field would get less there.
Someone said, can you use magnetism to direct the flow of a designated frequency or the reverse frequency to direct magnetism? You can use a magnetic field in like a certain way in relation to the flow of an electric current, and it can direct the flow of the quote unquote charged particles to create a certain frequency. Yes, you can use a magnetic field to manipulate the vector, thus get a different frequency. Indeed, I think that's what you're asking. Trying to keep finding questions. Do you have anything to say about that? I mean, it wasn't the most specific question.
Yeah, magnetic fields, frequencies. I mean, it's kind of part of a frequency, You have your electricity and your magnetism, transverse longitudinal wave collapsing in on itself and traveling for a certain amount of distance before it does it, and that's considered a frequency. So the bigger the wave, the smaller the frequency. So in a certain distance, we'll say that's 1. And then if you go up to 2, it'd be the wave would break here and it would take 2 times to get to where 1 is. I still don't know what the lowest standing wave really is. I don't know.
What's a standing wave? Yeah, I want to read this real fast. It says, an ionic wind generator, also known as a vaneless ion wind generator or power fence, is a device that creates electrical energy by using wind to move charged particles across an electric field.
Yeah. Yeah, that's how MIT did its silent drone. They had some kind of high potential on the top of it and a low potential near the base, and the wind created from that thrust down between those 2 different Gaussian surfaces that are releasing the charge was lifting it up. It's kind of just like your air purifiers, your ionic breeze purifiers. And it's actually collecting the dust particles as it's pushing the air through the fan. It's really neat, and it's all done with electrostatics. They've been trying to get it to work on computers, but there's a heat factor involved as well. And adding more heat to a computer is never a good idea. Yeah. But yeah, so So electrostatics is not like the electricity coming out of your wall. You know, you plug that thing in and the light turns on instantly, right? In your house. Well, that's not how electrostatics moves. It does when it breaks down and you have lightning or, you know, the little static charge from your finger to the doorknob, things like that. But that's not, you know, electrostatics. That's the breakdown of the electrostatic field. But when it is just the electrostatic field there, it moves much slower. Now, when you come to a point, it's going to move faster there. It's going to try to release from there or gather in from there, either way. You know, if you're surrounded by high potential and you put your finger up in the air, it's going to gather more at the tip of your finger than it is, you know, on your shoulder or your back or your leg. It's just how it works. So these are those little things, those little intricacies about electrostatics that I want everybody to kind of start grasping. Because the stuff that, you know, Austin's been getting into the debates with all these people about have to do with the electrostatic field. And if you really want to comprehend what he's saying and understand, you know, how it works, then these are these little things you kind of have to comprehend. So we had conduction, which was the paper was actually touching the Gaussian surface, that sphere ball at the top of the Van de Graaff generator. And then it would reach out equipotentially when it was a nice sphere. But as soon as I added a sharp point to that, it changed the electric field. Now most of the potential energy was rushing out of that nail point, and you could see it because the paper wasn't standing on end anymore. It's kind of drooping over. You know, it was still lifting it up a little bit, but it wasn't really giving, you know, like it was when the nail wasn't on there and it was all equal everywhere. So the shape of things determines how well the electric field is passing to the surrounding area or gathering. That's one of those things I want people to, you know, get a hold of. And then at the end there, ionic wind. When you do have these points or these things, you can actually feel the wind coming off of the tip of that nail because it's moving the particulates in the air, whether they be whatever gas is, I don't know, little molecules. I've never seen a gas molecule, I don't know. But whatever it is, you can feel it moving. You can feel it with your hand. You saw it, the smoke being blown away.
Yeah, gas particles, whatever. Super chat. Somebody asked me to. This is Mac Gary 2022. $10 super chat. Somebody asked me to explain Halley's Comet if I didn't believe in outer space. Is there a good video or explanation I can give him? Thanks. Well, for one, you should obviously say to someone that brings stuff up and phrases the question like that, I don't believe in what they say outer space is, but I know that there clearly is something above us that can be called space. And it has all kinds of different seemingly electromagnetic phenomena in it. So I will show you this real fast because I saw a super chat. I Googled an image to show you of its orbit. But it's an ellipse, which here we go. It's an ellipse. If you see the ellipse in relation to the sun, they say that it has retrograde motion. This is a kinematic equivalence with the stationary Earth. It could just be moving in relation to the sun. This would fit perfectly within the neotaconic system. Within a stationary Earth, it would just move, it would slow down in relation to the background stars. So here you go in relation to the quote unquote sun, which of course you see at the interior planets. You know, the Earth. It's basically could just be doing the same thing from a geocentric position. You could transfer it over. So the ellipse, of course, fits perfectly within a magnetic field, Peirce element. This is where you get ellipses. So I don't know why it wouldn't work. You're asking what it is. Well, I mean, they don't even know what it is. Good question. I mean, I think they claim they see it every 76 years, and it was first found, I don't even remember, 1600s maybe.
Something like that.
Yeah, but I mean, it looks like everything else. There's like electromagnetic phenomena that moves in ellipses in relation to a torus field. Seemingly, everything has different torus fields, and that's what we see. Their model sucks, and we're about to talk about that. So, why would we believe in their model? The model sucks. It's been disproven. So,
Yeah.
yeah.
Yeah, I think it's some kind of electromagnetic phenomena. With a light and a little couple prisms and stuff like that, or a little hemispheric globes, you can make things that look just like comets on your wall. There's videos on my channel of me doing it.
Yeah, I mean, he asked if there's a video. I don't know if anyone in the chat can drop that there may be a video about it, but I've never covered it in depth or anything. But
No, because I don't believe the information we're getting is accurate when it comes to that kind of stuff.
you see it once every 76 years, bro, or something
It's
like
a
that.
ball of ice and rock that
Yeah, of course, that's ridiculous. We're supposed we
never
saw it in the
burns up
80s.
completely.
Supposed we saw it in the 80s, and then we're supposed to see it in 2062 or something.
Yeah.
I was just looking it up. So yeah, I mean, everything in the sky is electric. If it's not, then it just defies everything else that we see. Not to say that it couldn't, but when we look at magnetic fields and then look at quote unquote galaxies and the spiral nature of them, it matches exactly what a magnetic field is. All of it matches what a magnetic field is. We see red and blue shifts, randomly distributed magnetic fields, electromagnetic retardation. So yeah.
And I wonder where
you
it
got?
actually comes from. Like if you were, say, on Antarctica, you know, around and had people all the way around it, who would see it first? Is it coming from the outer lands, or does it just kind of appear in the sky one day?
That's a good question. I don't know. Could it have been there for a long time? Were there ancients that did see it? Who knows? I've never seen it. I wasn't even alive when it was supposedly seen. So I don't know.
Yeah, I was like 5 or 6. I think I have a vague memory of my mom or dad being, "Hey, look," and it, you know, without even with binoculars and stuff, comets don't look all that spectacular. It looks like a star with a little tail on it.
I mean, I just don't know why it couldn't be like a electric phenomena moving around the central axis of a torus field. I mean, in fact, I know that's the only thing it could be, in my opinion. So, Justin Johnson gifted 5 GLOBEBUSTERS membership. Thank you so much, brother.
You're the man, Justin.
Yeah, bro. Stay holding us down. Shout out to my boy Justin, and shout out to all the new members of the GLOBEBUSTERS. And Heracles, welcome to the GLOBEBUSTERS. Thank you for getting a membership. 289 watching, but only 83 likes, says Daryl Davis. Yeah, smash the like button. Smash the like. And we're at 86. Everyone just smash the like for us, please. Help us get the algorithms. All right. I didn't see any more questions. Do you you got anything else you want to say real quick?
No, I'm just that, you know, you need to start, if you want to comprehend what Austin is saying, we'll go over it slow. Conduction. It means passing electricity through touch. Okay? It means that 2 physical materials are actually touching each other, passing electricity from one to the other. That's conduction. Now, induction, you know, whether it has something to do with the air actually being a conductor, even though it's mostly, we call it an insulator, but it's still like you know, even though something's an insulator, this is another one of those things I want everybody to remember. I'm going to keep drilling this home. It just means that it holds on to the electricity longer. Like the electricity that is on that surface will be there at that potential for a lot longer, unless you come up and touch it through conduction, you know, and then take away some of that extra potential and ground it out. Otherwise, that object it will eventually get to the same as its surrounding area, but it takes longer for an insulator. So insulator, the electricity moves slowly across the surface. Conductors is something that it moves quickly across, and conduction is when you have two materials touching, passing electricity from one to the other. And then to wrap it up, shape. The shape of the object that is either accepting the electricity or releasing it, the amount that's released at the surface is shape dependent. So if it's real pointy, there will be more potential coming from that spot. If it's shaped like a bowl, there will be less. That's just how it works. Okay, that's the end of my rant. You got to
Cool, I
learn these,
guess.
folks. You got to learn what these words are and what they mean.
Yeah.
You know,
Yeah, and just to reiterate, I mean, you have static discharge, that is movement. You have electrostatic induction or transference, that is movement. Yes, it's called static because it's relatively still. That's why we call it that. Technically, nothing is still ever. But if there's anyone trying to tell you that you're discussing like the vector preference or anything like the bias on the earth, like, oh, why do things go down? Because of electrostatics. Statics means still. I mean, all right,
I
bro.
mean,
They don't
okay,
understand.
yeah. If it was all the same charge, sorry about that. Everywhere with between the field, you know, between your two Gaussian surfaces, if you had a charge that didn't change, then yes, then that would be static. 100 per, you know, there is no movement, there is no flow, there's no potential difference. But once you introduce a potential difference, then you're going to see flow. That's just how it works.
Hey, can you tell me real fast if you hear? I'm gonna play this video real fast and then tell me if you hear it. Yeah, just let me know if you can hear this.
Okay.
What? Your browser has blocked your screen. Click the screen icon in your address bar. What is going on?
Technology. Gotta love it. Yeah, exactly. Kav LVI. Sorry if I butchered that name. But cathedrals and stuff. When you start looking into the way a lot of these things are shaped and stuff like that, sorry, and the way that the tops are shaped and things like that, you get a lot of things that come from magnetism and electricity and how it flows. So yeah, I think somebody was using this information and they were actually building it into the infrastructure here on Earth at one time. I mean, pyramids are great, you know. They have it comes right up to a point, and the point is at the highest spot. When you're
Dude,
dealing with electricity, that's perfect.
someone said, how do waterfalls work with electrostatics? Dude, oh man, there's an electric field on the Earth, bro. Okay, we have charging, the process of charging, misidentified as positive charge, building up, higher we go. We have discharging, misidentified as negative charge at the surface. We covered this in depth a couple weeks ago. That gives us a downward bias. There's a measurable downward electric current. Everything's seeking equilibrium because pressure is mediating relative to that. So the primary reason that things go up or down, including a waterfall, is the object's relationship to the medium, including both density / buoyancy, right? So relative density and the electric relationship between the object and the medium. This we covered also cannot be eliminated. If you're in a Van de Graaff generator, you can still measure vertical electric gradient. We covered that even in a vacuum, you have impedance of free space, you have vacuum permittivity, that's electric permittivity. It can still be measured. There's no way to avoid the fact that whatever medium that the object is in is going to have a relationship with the object or vice versa. So things go down because of those variables. All right, tell me if you can hear this, bro. Cool?
Yeah. No.
Oh my goodness.
I can listen on.
No. All right.
There's a question in chat real quick from I
Yeah,
am
cool.
Ion's cat. Could you have solid spheres for the Van de Graaff generator, or do you need hollow spheres? Same question for the Wimshurst machine. Also, does the material matter? The material, you just like for the Wimshurst, I believe it's copper and aluminum that's rubbing up against each other, creating the electrostatic friction. And then rubber and aluminum for the Van de Graaff generator. Now, the Wimshurst does have solid spheres that it has at the end of its points. They are solid. And for the Van de Graaff generator, it's hollow. I think they do that just for saving material. For one, a big, giant, solid piece of aluminum that big would be real heavy. So the lighter, but I don't know if it would hold more, be able to hold. Yeah, it probably would be able to hold more potential. I'm not really sure. But you don't need a hollow sphere. But they probably do it, they want the nice big giant spheres, and the bigger it is, the heavier. I mean, that would be a real heavy piece of aluminum that were that big. So no, I don't think so. And the materials, they just have to, I mean, you can create friction between all kinds of materials, but you really want one that's going to be more of a conductor in one hand and one that's more of an insulator in the other. So then you can separate that charge that's there better, if that makes any sense.
All right, you should be able to hear this now. Let me just double check real quick.
The Dark Energy Survey has
Yes, I can hear it.
Cool. All right, cool. So someone said, "Oh no, not this lady." Yeah, I just want to kind of show you guys what's going on. We call the show Heliocentrism, Shrouded in Darkness. Of course, people are probably familiar with the terms dark matter and dark energy. And these are just major problems in the belief of heliocentrism, right? So before someone wants to tell me that they know that there's some magical icy rock flying around the sun, and how do you explain it? You need to explain how it's even possible that the Earth is in fact moving around the sun itself in an ever-expanding universe. That's the prerequisite for any other types of claims about what's going on in space for them. So I'm going to play this video real quick, and we can commentate. If you want to jump in, Zach, just let me know.
Cool.
And I think this kind of speaks for itself. So, all right, I'll make it full screen.
surveyed dark energy and found that our universe. The Dark Energy Survey has surveyed dark energy and found that our universe is unlikely to rip into pieces. I think that's good news. Let's have a look. Dark energy is the name that astrophysicists have given to a hypothetical ingredient of the universe that makes the expansion of the universe faster. So it's not that dark energy causes the expansion itself, it makes it faster. Dark energy should not be confused with dark matter, which does contribute to the expansion of the universe but doesn't make it faster. Dark energy isn't like anything we know. I'm not sure exactly why this stuff is even called dark energy.
All right, let's pause it right there real quick. Look at the chart. Look at the chart. This is the percentage of the universe in their religion. And it says 74% dark energy, 22% dark matter, 4% normal matter. Okay.
Yeah, I think your cosmology might be wrong when you have to do that. Just say, well, in order for us to be right, 96% of what's really out there has to be undetectable to any of our sensory array, anything we have.
I mean, how hilarious is that? Admittedly, they don't know what either one of those things are, but accounting for the 4% with their theories of gravity and their model, they're required to have this question mark on the remaining 96%. That 22% of dark matter accounts for like over 84 to 88% of all matter in the universe, allegedly. So they don't even understand or know what 88% of the quote unquote matter and mass is that they need. This is specifically about dark energy. We'll keep going, but it is hilarious that anyone would come representing this model with any type of arrogance, any type of position of superiority. It's the dumbest thing I've ever heard.
They have to. That's the only way it works. You know, when you're trying to deceive people, you have to be matter of fact about it. And when you're pompous and arrogant, people tend to think you know what you're talking about for some reason. I don't get it either, but it works. It's that small hat magic.
I guess Simon Dan did a video on me recently. I haven't watched it, but and I know that's what it is there. It's like if someone can say something confidently enough, frankly, FED does it too. If they can blatantly misrepresent you or whatever, as long as they say it with enough confidence, it like can cast a spell on the audience where they're like, there's no way that a normal person could ever be so confident and arrogant and condescending about a point.
Yeah, unless they're right. Yeah, exactly. Yeah.
Crazy because it works. It absolutely does work.
So I always go check stuff, folks, when you hear it. Don't just, even the stuff I say, even the stuff Austin says, everybody, go check it. You learn so much. You learn even more that way because you're going to learn something while you're researching that. But yeah, all those answers I answered for people just now, don't take my word for it. Go check it. You know the words now. You know what they mean. Yeah, go do the research yourself. And if you can, play with it yourself, test it. That's how you really know. I mean, research and reading, words can tell you a lot, but actually doing it is when you know it works and you know that this is happening.
This is what I would suggest to people about this subject. Don't let people play these games where they try to get you to not talk about it or pretend it's irrelevant. They'll be like, oh, well, it works perfect on the solar system. That's called a red herring fallacy. That's non sequitur. That doesn't sequentially follow the point. Or if they try to convince you that it doesn't matter, or the solar system still works, it just doesn't matter. No, if you claim the Earth is a ball that's tilted, wobbling, spinning, and orbiting the sun, side note, you have to claim all of those things. It's a package deal. And if it's in fact doing that, then that has to be in a system where the sun is moving through the galaxy, the Milky Way galaxy. That has to happen. And it has to be moving like 500,000 miles per hour, dragging the Earth with it. And that galaxy has to be moving through space over 1 million miles per hour. You cannot pick one of them and say, let's just talk about the solar system and the Earth moving around the sun 66,600 miles per hour. No, if that's the case, then it must be moving with the sun 500,000 miles per hour through the galaxy, while all of it moves with the galaxy through space at over 1 million miles per hour. Basic understanding of their model would require you to understand. You have to have all of them, just like you can't have the rotation of the Earth without the orbit. You can't have the orbit without the rotation, right? You need both of them to explain the observations that have been seen. So all I have to say, dark matter and dark energy is a heliocentrism problem. The number one tactic I hear is people try to say, oh, they just gaslight you, right? And they talk about, oh, you just want to talk about fringe science. That's the way science works. This is the cutting edge of modern science. And you want to talk about that as if somehow that makes the Earth flat. It's just gaslighting, and call out that is a poisoning the well fallacy. That is a red herring fallacy. That's a non sequitur, right? It's a package deal. So that's basically the only thing that you're going to hear in response to this. Some people will go as far as to say, we know dark matter exists, we know dark energy exists. Insanely incorrect. All right.
That's an oxymoron.
Yeah.
It's dark because you can't, even pick it up on any of your best sensory equipment. This is a mathematical concept that has to be there. That's it.
When they say we know it exists, what you say is that's affirming the consequence. I do encourage people to learn the fallacies, which is if the Earth is moving around, if the heliocentric model is true, and my belief in gravity is true, then dark matter must exist. Therefore, dark matter must exist. Okay, that's just wild. Okay, and it's begging the question, which is informal. It's depending on how they phrase it, it's an affirming the consequence. It's a reification fallacy, taking a concept and assuming and treating it as if it's concrete and real. So
you're just not even close. 96-4.
Not even close. Not even
even
close.
close.
We're gonna let her explain it to you. She's already drank the Kool-Aid. She's a pretty famous person from their side, and you're gonna see exactly how this works. So, all right, cool. I am. We'll just keep playing. I just wanted to make sure you guys saw the chart and fully understand. I mean, people will try everything they can to avoid this. They'll misrepresent it, and you have to just kind of know your stuff. And we'll cover some of it, and it's pretty simple. And this should wake up any honest person, right? If they actually understand it, which is why the vast majority of people don't. They're told about dark matter as if it's an amazing discovery, when in fact it's nothing like that. So, all right, let's keep playing. See what
Dark
this
matter matters. Dark matter lives matter, says Benny. That was a good one.
They've came up with dark flow at this point. Supposedly this giant thing outside the visible universe pulling stuff towards it because the distribution doesn't work. Some things are going the wrong direction at the wrong speeds. Anything that they just can't verify, detect, or even show as possible, they just call it dark, meaning that it doesn't interact with the electromagnetic spectrum, i.e. light. There's no way to detect it, no way to find it, no way to know what it is. All right, so let's bring it back just a little bit, and then I won't interrupt for a bit. If you have anything to say, just jump in, bro.
Will do.
Did it freeze for you too?
Yeah.
Right,
I saw you hit the button, but it didn't.
Yeah, they're trying to come at me, bro. No, I'm just kidding. All right. So let's just go over here. We're gonna get it to work. Don't worry.
Gotta hear Celine out.
Yeah, and I will go ahead and say this. Dark matter, for example, was supposedly quote unquote discovered in, let's see, supposedly discovered in 1933, I think. Fritz Sawicki, 1933.
Illuminati confirmed.
Yeah.
There's a lot of that. Seems like, what would you say, between 1880 and 1930 is when physics, real physics, just took a big old left turn and went off into La La Land.
Yeah, pretty much, man. They gave the reins to the Grabla, Einstein.
It's just a shame. Imagine how far we could be right now. Flying this, flying that, all kinds of free energy and yeah.
Yep. All right, here we go. We should be working now. I guess we'll go full screen. All right, let's hear her out here. Why does it keep freezing?
That's crazy.
All right, we'll definitely get to work with this.
Wow, that's weird, Austin.
That's pretty weird.
Gotta say.
Pretty weird because I have like insane internet. All right. And yes, I've cleared the cookies. There's like basically nothing on my Google Chrome. We're gonna try Firefox real fast.
Dark matter.
But 1933, Fritz Sawicki looked out at the galaxy clusters and saw that, according to gravity, there was only 1% of the mass needed to actually have the amount of gravity they needed for their model to keep the galaxies in the cluster. So if you have a theory and you had to upend all physics, throw out ether, undermine electrical field theory, completely change everything about, completely throw out Newtonian physics just to deal with Aries' success misnomer that it was a failure. Aries failure is what it's called, but it was definitely a success, right? It verified that there was some type of ether drift because we don't talk about that right now, but, and then you have Michelson-Morley, right? Obviously detecting a fringe shift, but not detecting what they're supposed to. So they introduced relativity. It was not because it was some random breakthrough. It was because it was required to save the heliocentric model and their cosmology. Then you fast forward to 1933 with this new version of gravity. It still has the same mass prediction effectively when it comes to the proportionate mass aspect. and it was off. So if you have a theory that's off by 99%, it makes a prediction, and the actual observation and evidence is off by 99%. What do? You keep your theory and then just make up some mystical mathematical fix to fill in the other 99% and claim no one knows what it is. It's never been discovered, but I promise it must be there. And then hold on to it for a century, still having no idea what it is. Of course, you'll never know what it is. It isn't any type of mass. There is no matter. There is,
It's no different than Einstein saying there is no optical test that can determine whether it is the Earth or the sky that's moving, but yet we know the Earth is moving. So we can't test it, but it's moving still because we say so. It's just it's an admission, really. Like, we don't know this, but we say it is this way.
All right, you're gonna have to let me know if this is like, oh man, let me know if this is echoing or anything. Okay.
Yeah, we'll do.
Like anything we know, I'm not sure exactly why
Sounds good.
this stuff is even called dark energy, seeing that it's transparent rather than dark and isn't even energy. But, well, it's certainly a catchy name. Dark energy is what determines the ultimate fate of our universe, how it'll end. Will the expansion get faster and faster? Will it slow down? Is maybe even a recollapse and a new beginning possible? It all depends on this mysterious stuff, dark energy. In astrophysics, the name dark energy isn't used for just one thing. It's a term that encompasses all kinds of different things which could cause this accelerated expansion. One of these types of dark energy is the cosmological constant, usually denoted with a capital lambda. So the cosmological constant relates to dark energy like a banana relates to fruits. It's one of many. The cosmological constant is, would you have guessed it, constant, and it's the simplest type of dark energy. But like there are other fruits besides bananas, there are other types of dark energy besides the cosmological constant. Astrophysicists characterize all stuff that fills the universe by the ratio of its pressure over its energy density. This gives a quantity that's abbreviated with W. Particles that move around fairly slowly, like you and I, for example, have zero pressure and zero W. That's astrophysics for you. If you look at your calendar tomorrow, I think you should keep in mind that you have zero pressure. Dark energy in general has the odd property that while it has positive energy density, it has negative pressure. For the cosmological constant in particular, the pressure is the same as the energy density, but with the opposite sign.
That is the dumbest thing I've ever heard.
I was just going to say the same thing. Even though it has all this potential, it has negative pressure. All this stuff, it has negative pressure. That makes zero sense. There's no such thing as negative pressure.
Bro, what even is that? It has positive energy density, enough to make space a concept. Physically accelerate and move and expand up to 4 to 8 times faster than the speed of light. But it has negative pressure, quote unquote. Think about how stupid that is. It's stupid on its face that it's like you have no evidence of it. You can't actually find it. Your only quote unquote evidence is the indirect evidence of the assumption that your other theory must be correct and can't be challenged because your model has to be true. So a philosophical bias, reification fallacies, affirming the consequent, begging the question, presupposing the very thing that you're claiming that you're verifying. And then you look over here and you see that it doesn't work. So you make up a name for it, call it dark, meaning you can never find it, saying you can't identify it, saying, oh, there's crazy amounts of energy in a vacuum. We see the energy in the vacuum on the Earth. And we say, well, we can use this energy that we see is in a vacuum. And then it's off by 10 to 120th power of what you need. So it can't be that. And then you say, okay, well, it must be something else. And you just keep on sitting here, and then you end up saying whatever this mysterious thing is that we can't find, can't define, can't detect must also be anomalous in terms of physics where it has negative pressure. What? How is this not like invoking a god? A pervasive, omnipresent energy that's causing the very existence and fabric of space and time to be what it is. You can't find it. You can't see it. You can't define it. It boggles the mind. It's beyond understanding. It defies all of physics, meaning it would be supernatural. It defies laws of nature. It's attributed to a force beyond. This is the definition of supernatural, attributed to a force beyond the laws of nature or current scientific understanding. So they're invoking something supernatural to keep together their cosmology that specifically tries to avoid the fact that there must be a supernatural. You know what I'm saying? It's bad, bro. It's so stupid. Negative pressure would be counter space. But what's so interesting about the whole thing is they clearly hijack an etheric framework in all of this. That's why I keep saying the geocentric model doesn't have the dark matter, dark energy problems. So how is it not at least 96% more viable?
Exactly.
There's no way around it.
And
All right, we'll keep
every
it on.
test that they've done through time that, would indicate one way or another, what's moving, has shown that the Earth is stationary. Still to this day, and Aries did it a long time ago, George Biddle Airy, I think his name was, the astronomer royale. I forget the actual date, even the year. I think it was the 1880s. But yeah, he came up
Aries
with this.
success.
Yeah, it was a great test. It's so simple yet so perfectly designed to tell whether or not it's the light above moving or the ground that's moving.
Yeah, if you don't know, that was the test that's falsified the rotation of the Earth. And you have like a tube of water. You look at the lights. The light should be displaced and hit the side of the tube by the spin of the Earth, because the light has to slow down in the water, quote unquote, slow down. So as it does that, and the Earth is moving, it should be displaced. But it was not displaced anywhere close to how far it should be. But it was displaced, though. It was slightly displaced. And that's the part that no one talks about. The fact that it's slightly displaced completely falsifies the claim that the Earth is moving.
Mm-hmm.
Right? Because they'll try to come up with, just like MMX, there was a fringe shift. They'll say, well, you can't detect the orbit of the Earth. You're not going to get a fringe shift because of relativity, and we're free falling and a geodesic path, and we're still going straight. And since it's going in a linear motion, you can't detect the circular motion because from the Earth, it's not circular. So that means it should be zero fringe shift. But we did detect the fringe shift in Michelson-Morley, and we've detected it every time we've ever done it. So, it's instrumental error because it can't exist. Same thing with Airy's failure, right? Any slight displacement cannot exist. It completely refuted the claim that the Earth moves. So it was an immense success, and it verified that not only is that the case, but on the surface, we can actually detect the spin of the sky using light.
Mm-hmm.
So now, many will argue that that is a very strong evidence for ether. Something is connected to the surface from the sky.
Oh, sorry.
And then giving that momentum, that angular momentum, where you can detect it. Something is happening, right? Just like something is happening if the light is going, quote unquote, faster, even though it doesn't travel. The rate of induction, the perceived illumination rate is faster, east to west, the same direction that the sky moves. And it gets faster and faster the higher you go. So in direct relation to the motion of the sky, we see that light moves faster that direction. So that's it. Anyway, these are the two primary things that made them change all of physics. So when your theory is wrong and demonstrably wrong by an egregious degree, in terms of dark matter, it was 99% the first observation. Dark energy, same thing, tons of problems. Well, just upend all of physics, completely change our understanding of the entire natural world with unverified, unfalsifiable religious terminology and mathematical concepts that transform and change every single fathomable way that reality works, simply in theory with no actual evidence, so that you can keep your theory alive, and then mix in all kinds of made-up mathematical band-aids. That is so far detached from science that it's laughable.
Yeah.
So, pretty crazy.
Sad, But people are waking up and realizing this stuff now. I know I didn't have any interest in physics before I heard about flat Earth. Even though I was a NASA fanboy and all that, it was an illusion. I didn't care how they got the stuff up there and all that kind of stuff. I didn't even question it. I just soaked up all that nonsense and, built the paradigm around it, the heliocentric system. But I never once tested it, never once. And as soon as I started, I just got this urge to test everything now, just to make sure that it, held true. So yeah, this flat earthers makes new physicists. Flat Earth does. Yeah.
Yeah.
It's
Yeah, that's crazy, man.
it's a huge wake up call.
We'll listen to a little bit more. I won't torture you guys too much, but I just want to show you. This is a recent video.
You have W equals -1. And this brings me to the new data from the Dark Energy Survey. They measured this W by looking at light from distant supernovae. The survey was conducted with a camera mounted on the Victor Blanco telescope in Chile that collects data in 5 different wavelength range.
Wow, they confirmed and measured it by looking at supernova that actually goes against their redshift explanation and prediction. And then by assuming dark energy must exist, they measured it by not measuring it, but by looking at light and assuming that there must be dark energy affecting the light. That's profound, bro.
It closely monitored about 1/8 of the total sky for a total of more than 500 nights in the years from 2013 to 2019. In the past few years, the collaboration have analyzed the data and are now publishing the results. In the new paper, they report that they found 1,635 new supernovae of type 1a. These supernovae have a well-understood light emission that follows a common pattern.
And that common pattern does not work with their model. Quasars and supernovas are the easiest way to refute their claim about redshift, which is that things are moving away from you, because that means the further away they are, the more redshift they should have. But you look at certain quasars, for example, they'll be way closer but have way more redshift than things further away from them, proving that that isn't the cause of the redshift. But then they'll turn around and they'll double dip and they'll be like, oh, it must be magnetism. You know what I'm saying? So magnetism can cause the red and blue shift. Is that what you're saying? I said that in my Flattoberfest presentation. I showed that mainstream article talking about how scientists were wrong about thinking a star was coming towards them. Then it explains the blue shift of a star had tricked astronomers into thinking that that star was heading towards our solar system. Turns out it was just the magnetic field. So they're admitting that the magnetic field can cause redshift and blue shift. You can verify this in the lab. It's electromagnetic retardation. And Wheeler has verified it. So with that being said, why can't we accept that's the cause of the phenomena? Because they have to have everything moving away from you in all directions at every single point in space to explain why it just creates the illusion the Earth's in the center.
Yep, has to.
Yep.
This is the Hubble constant.
Exactly. Yes. And then dark energy is the cosmological.
I'm learning.
Yeah. Yeah, man. So you have the Hubble constant, the rate at which space supposedly accelerates to create the illusion we're in the center, and cosmological constant, the energy that does that. And as she said, which is just ridiculous. I don't know what she's talking about when she says it doesn't cause it; it just causes it to speed up. It doesn't cause the expansion. It's like, oh, okay, thank you for, And then they have Hubble tension, which is where the different measurement methods that they use, they're not measurements, right? They're calculative assumptions built upon reification fallacies that they use to measure the supposed expansion rate don't match up. It's called Hubble tension. You can't get them to match. They should be the same. They should be measuring the same thing. So why are they different? Well, guess what they say? Oh, it must be instrumental error. They can just always claim that it's instrumental error, but at the same time, they can invoke these instruments as like definitive evidence of something.
Now, what if the light just dims? Would that start showing blue light if it's at one frequency and then it's slowly dropping in frequency?
Yeah, an argument for like red and blue shift is the attenuation of light. And that's like what Halton Arp said. I think it's all magnetic. It could be a combination.
Yeah. I've just, when I was doing a lot of research on Polaris, I had seen that all throughout history, and we just had one recently, Betelgeuse was dimming or brightening, or it was changing just last year. But even like the pole star in the 300s almost was non-visible at all. They could barely see it because it was dimming out so much. And then it came back. Another one happened in the 70s. I forget which one that was. It was dimming for like decades and then started brightening back up in the 70s. So these things are constantly getting brighter and dimmer, and it seems some of them take like, decades to go from its brightness to it. It's not like it's just happening rapidly all at once, like flipping a switch. It's really slowly dimming down or really slowly brightening back up. So there's things up there we don't know what's going on.
Earth Strip Bear says 100% of the universe is made up of a brand new material. It's called doesn't matter. Dark mind over dark matter. You guys got jokes in here.
Yeah, there was a good one earlier. Dark
matter
energy
matters.
is held back by white matter supremacy. I got a kick out of that one.
Yeah, man. Gravity's just trying to hold her brother down. All right. Let's see what we got. We'll watch a little bit more. It's pretty interesting, man, because it's an amazing wizardry tactic. What they do is they invoke the anomalies, is what they call them, which is a fancy word of saying the pseudoscience doesn't work. And they actually invoke the discrepancies as proof or evidence of what they're saying. It's brilliant. So it's like none of this works with their model. They're like, new dark energy measurements. We're getting closer to. No, dude, you're measuring more how you were wrong. It's impressive, honestly. And I'll say with just to visualize for the people what I'm saying. This is a magnetic field. It's a parallel cell image. It's another one, top down. Here's the one that'll really give you the visualization. If you were to flip that over, you'll see that it's diverging out. And so here is like an animation of it. I think that we're in a giant one of these. That's what all the evidence says. We are on that little green plane right there in the middle, right? The block wall, the dielectric inertial plane, the axis of orbital symmetry. And so if you're down here, you have the giant vortex. We're detecting it. Explains maybe why the sky spins, huh? Makes sense, yeah. You have all the ellipses within this. And then I think that there's a giant divergence out from the center of this realm. And that's why that divergence is causing redshift. And it's going out, up, back down, all the way out. And then you're going to see a huge amount of redshift. It's funny how they then say, oh, the universe is flat. Well, isn't that convenient? Yes, because we're on this plane inside of a giant torus field.
Now, do you think that the torus field comes like, do you think we live within the bottom of the torus's shape, or do you think we extend out? Because when I'm looking at this picture, the little square it makes in the center, if you cock your head 45 degrees, where it says magnetism vibration, that little square, if you build a little square in there, I almost think that's like the only place that we could live. We couldn't live out on the fringes where it's going all crazy. See, like in the center, it's all coming in the same like path almost. It's almost making the dome. If you were to draw a line up from one edge.
Oh, it does. It makes a dome.
Yeah.
Well, it just all works too good almost. If you see all these other lines coming out of it, like, yeah, you have things moving all around us in different ways. Look at all these different lines I can catch. Right.
Yeah. Oh, yeah. And different elevations. Yeah.
Yeah,
all of the paths that the luminaries take, you can recreate with magnets and lights. You can. I've done a bunch of them. I think all the way up to Jupiter that had 12 rings. And then I needed a bigger ferrocell to do Saturn. I think that has 27 retrogrades. It's all about the retrograde motion of them. Like Mars does 2 retrogrades in its path. Venus does 5, I believe. I forget what. Jupiter, I think, had 12. And then I didn't do Saturn because it had too many. But yeah, when you look at their path over a flat Earth, they're all magnetic patterns that they're traveling.
Yeah, exactly, bro. They all fit perfectly within that. It's another coincidence. Let's actually let Einstein himself explain to you how we know that the Earth is in fact moving multiple vectors, tilted, wobbling, spinning, and revolving around the sun, flying through the galaxy 500,000 miles per hour, flying through space. Let's let him tell you how we know that everything is in fact moving, including space, over 4 times the speed of light. But when I was a student, I saw that experiments of this kind had already been made, in particular by your compatriot Michelson, of course, Michelson-Morley. He proved that one does not notice anything on Earth, that it moves, but that everything takes place on Earth as if the Earth is in a state of rest. That's how we know it's moving. All right.
That's
We go a
crazy.
little further.
Oh,
Yeah,
real
it's
quick,
crazy.
shout out over on Rockfin. Sorry, I didn't catch him right away. Realm Actor. Haven't heard too much about the Southern Twilights lately. Status.
You got to make those measurements 6 months apart. So we're trying to get it all ironed out. I don't know exactly where we are with that. There's a special group in Telegram for that though.
Yep,
So if
go
you want
check that
access to
out.
the group, yeah, if you want to partake or access the group, you can message me. I don't think it's open to everyone. Want to keep the trolls out. Oh yeah.
And then Jay Win, $5. No message. And Fishhead, Montana.
What is
Thanks, Bob. Long live GLOBEBUSTERS. Absolutely. Yeah, Fishhead, Montana is a place, man, I wish it wasn't so far away. Magnet test drop. There's like 120-foot drop there, an overhang. It's all rock, and it drops into water. It's just like way up in Montana, way up there, which is a ride.
Daniel Goglin, $5 super chat. Thank you, bro. Says dark energy is Dunkel energy. Just thought I'd share. I don't even know what that is. But thank you, man. Thank you for the support.
Absolutely.
Right. Come back over here. All right. Sorry, it's not the best, but we got to work with what we got. Oh, Iron Maiden, Liz the Iron Maiden. Thank you for the 199 super sticker. We love you too.
astronomers call standard candles. Astrophysicists believe these supernovae happen when a white dwarf eats up a nearby star.
You see how everything looks like a magnetic field with the vortex? Is that just a coincidence or
Everything?
Yeah, like everything in their model is just hijacking electromagnetism, bro. Like seriously, whatever. I don't see how it's not obvious to people at this point.
Gets too much and explodes. Who doesn't know the problem? If one measures both the brightness of the supernovae and the frequency of their light, one can tell how fast the supernova at a certain distance is receding from us. This way, one can use them to infer whether the expansion of the universe is getting faster or not. So this
Okay, if that's true, then if we use this same equation and we make an observation and it doesn't match at all, then if it's way too close to have that amount of redshift or it can't be receding away from us that fast, then that would prove your model's wrong, right? No, we can use this. We can use the equation and we'll know exactly what's going on. But whenever the equation shows us that it's not in any way possible in our model, we can just ignore it and call it an anomaly and then keep claiming the equation proves what it doesn't.
And they don't even hide it. They don't even hide it. That's
say
the
the word
craziest
anomaly
part
a lot.
about it. Yeah. It's just an anomaly, you know, even though it totally destroys our paradigm in this model that we've built. Yeah.
That's just so the opposite of how physics works. Say you have a theory in physics. So you want to do a scientific experiment, right? You have an observable, naturally occurring observable phenomena, deep into variable, and you're like, okay, let's figure out what's going on here. Like, I want to know what causes this. So we're like, okay, let's have a hypothesis, like a cause and effect relationship test. So like, okay, I theorize that this is going to be the cause of this dependent variable. So that's going to be our independent variable, right? And then we're going to test it. We're going to see it if it causes it or whatever. If we have some type of theory and then we start to make observations, we're like, okay, I have a theory that this causes this. You're supposed to verify with the experiment. None of that is possible with this stuff. Then if you go and you introduce different variables or control different variables and you see, oh, wait, it doesn't work. That can't be what's actually causing it, because when we test our theory, it doesn't match the predictions of our theory. Then you're like, okay, our theory was wrong. We have to scrap it. We have to come up with something else. But the way it works now is if no one else can come up with a better theory for the model that is presupposed, then they just keep it there until they think someone else can come up with a better one. And they think that is real science. That is not how it works, though. You are never afraid to challenge your initial presupposition in science. In actual science, that's the whole point. Think about how many times all of science has been uprooted and rewritten. That's how physics works. That's how science works, right? We get things wrong.
Mm-hmm.
But whatever. So I just think it's funny that they talk about this. They talk about these things like this equation with such like false confidence. It's ridiculous.
Supernova at a certain distance is receding from us. This way, one can use them to infer whether the expansion of the universe is getting faster or not. So this tells us something about dark energy. It's the same idea that the 2011 Nobel Prize in Physics was awarded for. That was the first evidence for dark energy. In the new data analysis,
The first evidence is just affirming the consequent, begging the question,
a Nobel
and reaffirming.
Prize.
Bro, what the?
These people got a Nobel Prize for it, so it has to be true.
That's what I'm saying. You think about how smooth it is. The first evidence of it, I mean, they even got a Nobel Prize for it. The first evidence of dark energy was measuring things that specifically don't work in the model. Literally. So it's like they brag about it as if it's a progressive step of knowledge in their model. And literally what this discovery and measurement supposedly actually, or what it actually is that it's showing the model doesn't work, and by how much. What the? I mean, it's incredibly effective, because when someone watches this video, they're like, oh man, this is awesome, right? They don't realize that what you're touting as a victory is literally a loss. It's such an effective method, bro.
Yeah.
I now found that the best fit value for W is -0.8, and the 95% confident band is within +0.14 and -0.16 around the best fit value. Now remember that the simplest type of dark energy is the cosmological constant, which has W equals -1. So that's just barely outside the 95% confidence band of the best fit value. It's a very mild tension, kind of interesting, but too insubstantial to think much about it.
Why do you say stuff like that? Like it's just weird, bro.
Interesting is that it
To think about, yeah.
tilts the balance against W being smaller than even -1. This matters because the value of W determines the ultimate fate of the universe. With W at -1 or larger, the universe will expand faster and faster and get darker and darker and colder in a rather boring way that's sometimes called the Big Freeze. It might
Dude, what is wrong with this person?
It also recollapse, which is called the Big Crunch. But if W was smaller, so more negative than -1, it would be much more dramatic. It's called the Big Rip. If that happened, eventually everything in the universe would move apart from each other at almost the speed of light, and this means that no forces could hold anything together, not even elementary particles. The new result from the dark energy survey, therefore...
And by the way, they already claimed that space moves over 4 times faster than the speed of light. And what they'll say is, well, no, you got to think about it in relation, and space doesn't have information, so it can go faster than the speed of light. What? What does that mean, bro? Like, if you empty out space and you have no physical limits or parameters, then you can make it do whatever you want. Well, yeah, it's a concept. So it's a concept that has no physical limits or parameters, so you can literally say whatever you want to about it. If they say it doesn't have information, then it can go faster than the speed of light. And to pretend that that makes them smart, it blows my mind. This is top level physics, by the way, bro. This is top level astrophysics and astronomy of today.
See,
not some crazy
I
flat
couldn't have
earthers.
done this. There's no way I could have accepted this stuff. I mean, this is why I didn't like physics in the first place when in high school. You know, it was kind of nonsense, a lot of the stuff I thought they were saying.
November said it. Even she doesn't have dudes tattooed on her. Talking about Simon Day. I'm gonna cover that hit piece on me. By the way, I've had a few people ask. Someone said I'm frustrated by the mainstream spreading their BS, but I don't go near their dwindling channels. Just ignore them and do my own research. Well, I will say that a very efficient way to do research on how to efficiently falsify their belief that they're propagandizing people with is to occasionally keep up to date with like the newest correction they have to make, or the new, whenever you see the word anomaly or you see new discovery, it's almost always the opposite. It's always like falsification. So there's a little bit more. I think it's pretty interesting.
Means that a big rip is unlikely to happen, luckily. I find it kind of hard to understand what a big rip would even mean, but I'm pretty sure I don't want to be around when it happens. What do you think, Albert?
So
Alright, it's
she
just
finds
too
it
cringe.
even hard to understand what they're
Yeah.
talking about. And
It's too
she's supposed to be
cringe.
one of the best ones?
I mean, she's like a YouTube personality, but yeah, she has some credentials. So I do want to cut the show short today, but should we move over to Rockfin for the last little bit of it?
Yeah, let's go
Cool.
mouth
All
off
right,
a little
so
bit.
we're gonna go over to Rockfin, and we're just gonna talk about whatever we want to. There are a few things I'd like to kind of mention that we clearly can't talk about here. So if you guys can drop the Rockfin link in the chat, that would be greatly appreciated. And yeah, I mean, basically, that we just covered one bit of it there, dark energy, but dark matter is like, oh, there's tons of missing mass, you know. And I'll just tell you, man, time will reflect that a geocentric model with everything being electromagnetic is the only way to explain what's going on. And I say that I'm not claiming like I know for a fact that's exclusively the only possible thing ever, because that would be a fallacy. What I'm saying is it's the only thing that I can find in any way that's even potentially viable. And this can be proven. You can just lay them up beside each other. And for example, they need a certain amount of mass to have a certain amount of gravity. So when they look out, they see, okay, there has to be a ton of gravity, but there's only a little bit of mass. They can't just say, oh, well, maybe it's a stronger gravitational field there for any reason, because it's only limited to mass, proportionate mass. If you have it being magnetic, you can have two magnets with the same mass, completely different strengths. One can be way stronger than the other. You are able to explain all kinds of different strengths, different movements, different locations, different redshift and blue shift, accepting and embracing the fact that it's all electromagnetic. And of course it is, because literally everything is. And I'm using that term properly defined, you know, as the conjugate expression dielectric and magnetic, joined at the hip, can't get rid of them. And yeah, I mean, I think it's crazy that people don't see how simple that really is. Like
Pressure
nothing's going to be able
mediation.
to explain it. Yeah, nothing can
Is it-
explain it without it. It can't be limited to quote unquote mass, a concept, volume times density. It can't be limited to that. It doesn't work.
Yeah, that's like archaic. Big shout out to Tony Coriolis over there on Rockfin. $5 super chat. Much love, brother.
Yeah, we're caught up on all the fan funding on YouTube. So thanks for kicking it 320 over here. Well, hopefully you guys go over to Rockfin. I think we're going to talk a little reckless about some stuff. And then you guys can just drop in the chat if you guys have any quote unquote forbidden topics you want to talk about in Rockfin. We'll cover it. Yeah, and we greatly appreciate anyone that comes over there to support us. That's what makes it possible. So please come over there and hang out. All right, cool. Yeah, Zack, everything you want to say to YouTube?
No, thanks for hanging out. I'll go over it again real quick. You know, you have electricity is always flowing from one object to another unless they are the exact same potential, which probably doesn't happen all that much, you know. So as the electricity is flowing, when it's static like a pond, it's moving quite slowly. It's not like a river. Now, if it's just on the surface of a conductor, then yeah, it'll move faster. But if you start getting into insulators, there's still electricity moving there. Now, when the two objects are touching each other and electricity is passed from one to the other, that's called conduction. Okay? Also, the amount of potential that is leaving one object and going, you know, away from it or being gathered is shape specific. If you have sharp points, there's going to be more potential entering or leaving those points of the object. If it's a bowl shape, you know, a concave part of a ball or something like that, and you make a big concave dent in it, there will be less potential in there. So points equal higher potential on objects. And when it comes to electrostatic, it's flowing very, very slowly. Always slowly. Current, like a river, moves faster when you have a current, but electrostatics is sitting still like a pond. And it just slowly dissipates, and it's around us. We're in like fish are in water. We are in an electrostatic pond. There is no place you can go that this electrostatic potential does not exist. Here on Earth, everywhere we've been, there's electrostatic potential. Now, if you go up high enough, can you get somewhere where it maybe neutralizes and is all neutral? I don't know. Never been up there. But here, down on Earth, as far as we can go, there is electrostatic potential. And it is in a gradient. And that gradient is creating a vector. It's just how it works. We'll get into all that a little bit later. But yeah, remember, conduction. You know, we'll get into induction and all that other stuff later, but today is conduction. Energy passing from one object to another through physical contact, through touch. That is conduction. And then the shape. Remember the shape. And that's it.
Nice. I will say, I just had an idea. Some people don't like the Rockfin chat as much. You can also go to the Telegram. I dropped a link in here, and I just created a topic in our Telegram called the Uncensored Live Stream Chat. So if you guys want to go pop in there, if you want to also follow along with the stream and say whatever you want to, or drop applicable links or whatever, you can do that in our Telegram. If you hate the Rockfin chat that much, I don't think it's that bad. But okay, cool. Thanks to Zack. Very good presentation. And he really breaks it down in a way I feel is very digestible. You guys should try to pay attention. It gives you incredible ammunition to understanding the world, pushing back against some of the nonsense that people try to say. Shout out to all the people on YouTube. We have 253 here. You guys should just go to Rockfin. The link is in the chat. The link is in the description. I think you can just go to rockfin.com/globebusters, which has constantly been popping up right below us. And it's about to be there again. So, yeah, we can just talk uncensored. And if you guys know anything about what's going on, they are rushing out complete censorship right now. And I'm going to cover it soon, but they're rolling out pretty crazy digital censorship that no one really knows about with major coalition of companies. And we think it's been bad so far, but it's about to be pretty crazy. And so we need to go ahead and start biting the bullet and migrating to the other platforms and supporting the people that we know will speak the truth off of YouTube alone, or we'll be caught off guard, you know? So let's go over there. If you have anything, if you want to hear like uncensored real talk, then we can do it over there. But cool. Thank you guys for kicking it. We'll see you guys on YouTube next week, and we're going to pop over to Rockfin now. So much love, and see you over there. Link in the chat.
Peace.
Peace.